The next question is, if the total volume of hydrogen and oxygen at the electrodes during the electrolysis of acidulated water is 33.6 ml at STP, the quantity of electricity used in coulombs is. This is the question that is based on Faraday's laws of electrolysis. We know that the number of equivalents of hydrogen produced at cathode is equal to number of equivalents of oxygen at anode during the electrolysis of acidulated water. But we know for the hydrogen to be liberated at the cathode, 2H plus 2 electrons giving H2. That means every 2 electrons when gained by 2H plus ions, one molecule of hydrogen is liberated. In other words, 2 electrons, if you take it as 2 Faradays, that is 2 into 96,500 coulombs of electricity will liberate 1 mole of hydrogen at STP. And 1 mole of hydrogen at STP is nothing but 22,400 ml of hydrogen at STP conditions. So it is 2 Faradays. Therefore, every 1 Faraday, that is, liberates 1 equivalent, that is 11,200 ml of hydrogen. Similarly, when we go for liberation of oxygen at the anode, for this oxygen to be liberated, every 1 Faraday, that is 96,500 coulombs, will liberate 1 equivalent of oxygen. In other words, 8 grams of oxygen. In other words, 1/4 mole of oxygen. And this 1/4 mole of oxygen, where oxygen being a gas, at STP corresponds to a volume of 5,600 ml at STP. So thus, every 1 Faraday of electricity when passed through acidulated water, we get only 5,600 ml of oxygen, while 1 Faraday of the electricity at cathode produces 11,200 ml. From where we can understand that the hydrogen and oxygen is liberated in the ratio of 2:1. Volume of hydrogen liberated to volume of oxygen liberated at STP is in the ratio of 2:1. So this is what is the basic point that is to be used in solving this question. And in the question it is given that total volume liberated is 33.6 ml. So out of the 33.6 ml, 2/3 of it, that is 22.4 ml of hydrogen is liberated at cathode, while the remaining, that is 1/3 of total 33.6 ml, 11.2 ml of oxygen at anode will be liberated under similar conditions. Now we are given that 22.4 ml of hydrogen or 11.2 ml of oxygen is to be liberated during the electrolysis of acidulated water. For this purpose, what quantity of the electricity is to be used? And we know that every 11,200 ml of hydrogen at STP, that is 1 equivalent of hydrogen, is given out by 96,500 coulombs of electricity, that is 1 Faraday. But how much of the hydrogen liberated at STP? 22.4 ml. So to get that 22.4 ml of hydrogen at STP, what quantity of electricity in coulombs is used? That is 22.4 ml into 96,500 coulombs by 11,200. That is, this 0 get cancelled, and 112 into 2 is 22.4, but we have here 22.4, therefore I'll put it as 0.2, and 0.2 into 965 is nothing but indirectly 96.5 into 2, that comes out to be 193 coulombs. So whether we have this 193 coulombs as one of the options or not, if so, that is the right answer. So we have 96.5, but we got 193. So this is wrong. Here is the 193 coulombs. It's already mentioned in coulombs. So 193 is the right answer, and this is wrong.